As always, I thank for your patience and attention, and I hope that you are all finding ways to learn the methods for finding the solution for a non-exact differential equation. You are at a right place, and it's very nice to be here with you all sharing my thoughts and ideas. And I hope that you feel like understanding this topic. And let's get into today's topic without any further delay. And today's topic is on non-exact differential equation, and there are five solution methods. And this is the fourth type, that is using integrating factor e to the power of integral f of x dx, where f of x is equal to 1 by n times of dou m by dou y minus dou n by dou x. And these are the few problems which are very, very important. And let's get into today's video for solving 2xy dy minus x square plus y square plus 1 into dx is equal to 0. As you can observe, the question should be in the form of m dx plus n dy. So we have to change these terms as m dx plus n dy, and we have to solve. And see here, the question here is 2xy dy minus x square plus y square plus 1 into dx is equal to 0. The first thing what I am going to do is I am changing this in terms of m dx plus n dy. That is minus x square minus y square minus 1 into dx plus this value is 2xy into dy is equal to 0. Now, this is of the form m dx plus n dy. Clear? This is of the form m dx plus n dy is equal to 0. Now, this value is m and this value is n. So, what is our m value? M is nothing but minus x square minus y square minus 1, and n value is nothing but 2xy. Now, I have to make a derivative with respect to y for m, that is dou m by dou y. So if I make a derivative with respect to y, so this will be minus 2y. So this is constant and this is constant 0. And what is dou n by dou x? So with respect to x is 1, so 2y remains. See, when we have to use this fourth method, so we have to go with, so as this is a non-exact differential equation, dou m by dou y not equals dou n by dou x. So we have to check the question whether by inspection, whether it comes through any formula or not. No, there is no chance at all. So the second method is we have to check whether it is a homogeneous differential equation or not. So there are two variables here, two variables here, two variables here. But there is a constant in between and it is not a homogeneous differential equation. The second type also fails. And the third type, the question should be in the form of f of xy, y dx plus g of xy into x dy. So this is not of third type. And we have to go with the fourth and the fifth type. So here we can easily observe that there will be a like terms here, that is minus 2y and plus 2. So if there are any like terms here, so we have to go with this. So f of x I'll calculate. So what will be the f of x here? So here is a shortcut that m is bigger than n. So whichever it is smaller, so we have to write like this. So 1 by n times of, if it is n, go with m, dou m by dou y minus dou n by dou x. Clear? So here f of x value is equal to, what is n here? N is nothing but 2xy. What is dou m by dou y? This is minus 2y minus dou n by dou x value is minus 2y. Clear? So f of x value is nothing but minus 4y times of, this is 2xy. So I can easily cancel these two and I can cancel these two. And what remains here? So f of x is equal to minus 2 by x. And now the integrating factor will be, see here, the integrating factor, the formula for if is, so e to the power of integral f of x into dx. So here if value will be e to the power of minus 2 by x into dx. So this is going to become minus 2 log x. So here this can be written as e power log x power minus 2. So x power minus 2 will be the integrating factor, and it is very clear as our integrating factor is nothing but 1 by x square. As it is 1 by x square, so if you multiply our given equation with an integrating factor, that non-exact differential equation is going to become an exact differential equation. What is an equation 1? So the given, so the question itself is an equation 1. Now I am going to multiply this one. So here it is the equation 1 and if is nothing but 1 by x square. And the question equation 1 is nothing but minus x square minus y square minus 1 into dx plus this value is 2xy into dy is equal to 0. If I multiply equation 1 with if, this non-exact differential equation is going to become an exact differential equation, and we have the solution formula for finding the solution. Clear? And next one, I am going to multiply the integrating factor as 1 by x square. So if I multiply, so this equation will become an exact differential equation. Clear? And now if I divide this one, this is minus x square by x square, this is minus y square by x square, this is minus 1 by x square into dx, plus this value is 2xy by this value is y square into dy is equal to 0. So if I cancel each and every term here, then this will be minus 1, this is minus y square by x square, this is minus 1 by x square into dx, and if I cancel for one time, so this value is 2y by x into dy is equal to 0. As this is an exact differential equation, what is the solution formula here? The solution formula is integral m dx. See here, it is integral m dx plus integral, the terms not containing, see here, terms not containing x, not containing x in n of dy is equal to c. See, let's get started to find out the solution, that is integral. What is m here? M is nothing but minus 1 minus y square by x square minus 1 by x square into dx, and the terms not containing x. So there is a term containing x, therefore there are no terms which are not containing x, therefore 0 into dy is equal to c. And now we have to integrate with respect to x. So this is minus integral 1 dx minus y square, I am taking it as a, considering it as a constant, 1 by x square dx, and this is minus 1 by x square dx is equal to c. So this is nothing but minus x minus y square. So this is nothing but x power minus 2 dx, and this is x power minus 2 into dx, which is equal to c. This is minus x minus y square, x power minus 2 plus 1 by this is minus 2 plus 1. This is x power minus 2 plus 1 by minus 2 plus 1, which is equal to c, or else. So this is minus y square. So this is minus 1. This is minus 1 by x, and this is also minus 1 by x. Straight away you can write, and see here, this is minus x plus this is y square by x, and this is 1 by x is equal to c. So if I take an LCM as x here, this will be minus x square plus y square plus 1 is equal to c, and this is going to become minus x square plus y square plus 1 is equal to c into x, and this is the required solution for the given differential equation. This can further be written as y square minus x square plus 1 is equal to cx. So this can be otherwise written as this one. So here, this is so simple to understand here. First of all, we have to consider, write it in the form of m dx plus n dy. We have to consider m and n, dou m by dou y and dou n by dou x. If you observe, so these two are the like terms here. So this is minus 2 and this is plus 2. So we have to go with this formula and see f of x is nothing but minus 2 by x, and after getting f of x we have to substitute here, and so we got the integrating factor as 1 by x square. So if I multiply throughout the equation with 1 by x square, see here, so this is m dx plus m dy, which is an exact differential equation. So here this is the formula for solving, and after solving, so this will be the solution here. And the second question is also so simple. So here it is, the second question is x power 4 into e power x minus 2mxy square dx plus 2mx square y dy is equal to 0. So exactly this question, so as you go with the solution, so this question is in the form of m dx plus n dy is equal to 0. So this value is m and this value is n. So I'll take m here first of all. What is m value? So m is nothing but x power 4 into e power x minus 2mxy square. What is our n value? That is 2mx square y. So if I make a derivative with respect to y for m, so it is constant. So this is y here. So this will be minus 4mxy. Clear? And what is dou n by dou x? So here is the x value. So if I send to front, this will be 4mxy. So if you can see, here is a chance of seeing that. So this is mxy and this is mxy. This is minus 4 and this is plus 4. So we have to go with the fourth model. So as you know that these two are not equal, as it is a non-exact differential equation, check the question once. So throughout the equation, so we cannot insert in any formula. So inspection method fails. And the second method is the homogeneous method. So they are not equally distributed, as it is x power 4, this is xy square. So the variables are not uniformly distributed, as it is not a homogeneous differential equation. 1 by mx plus ny integrating factor fails. And the next thing, third question, if you come, the question should be in the form of f of xy y dx plus g of xy into x dy. So this is not of the third kind also. 1 by mx minus ny also fails, and we have to go with the fourth or the fifth method. So as you see, these two are of a like terms, and therefore we have to go with f of x. So f of x value, if I calculate, see, whichever it is smaller, I have to take. This is m and this is n. So we have to take like 1 by n times of. If it is n, go with m. Dou m by dou y minus this is dou n by dou x. Clear? And now if I substitute, so if I substitute all the values here, so f of x value is equal to, so f of x value is equal to 1 by n value is nothing but 2m. This value is x square y. What is dou m by dou y? This is minus 4m xy minus dou n by dou x value is minus 4m xy. Clear? Minus 4m xy. So f of x value is equal to minus 4 minus 4. This is minus 8m xy divided by, that is 2m x square y. Now I can cancel these two. So x for one time, m, and this is also 4. And therefore f of x value is equal to minus 4 by the value here is x. Now we have to go with an integrating factor. So what is the formula for the integrating factor? Integrating factor is nothing but e to the power of integral f of x into dx. And now, so the value here will be, if I substitute f of x value, so this is integral minus 4 by x into dx, and which is equal to e to the power of minus 4 into the log x. So this value is going to become log of x power minus 4, and this is x power minus 4. And now the integrating factor value is equal to, so what is our if now? So if value is going to be 1 by x power 4. So this can be written as, so as you can write this as 1 by x power 4, and therefore our integrating factor is 1 by x power 4, and therefore if you multiply throughout the equation with the integrating factor, this non-exact differential equation is going to become an exact differential equation. See, clear? Now I am going to multiply the integrating factor, that is 1 by x power 4. So we got if value as, so if I write if, this is 1 by x power 4. So now I am going to multiply equation 1 with the integrating factor. So if you see, this value is x power 4 into e power x minus 2m into xy square into dx, plus this is 2m x square y dy is equal to 0. As this is a non-exact differential equation, if you multiply with the integrating factor, that is 1 by x power 4 throughout the equation, and this is going to become an exact differential equation. And see, each and every term I'll divide. So this will be x power 4 into e power x by x power 4 minus this is 2m xy square by this value is x power 4 into dx, plus this value is 2m, this is x square y by x power 4 into dy is equal to 0. Is equal to 0. And now see, I can cancel these two. So, and I can cancel this for one time. And see, I can cancel this for two times. And this is going to become e power x minus 2m. This is y square by x cube into dx, plus this value is 2my by this value is x square into dy is equal to 0. And now this value is an exact differential equation. As it is an exact differential equation, the solution formula here is very clear as, see here, this will be integral m dx. So this value is integral m dx plus integral the terms not containing x, the terms not containing x in n of dy is equal to 0, is equal to or c. So here if I substitute all the values here, so what is integral m dx? So this is integral m. M is nothing but e power x minus 2my square by this value is x cube into dx plus the terms not containing x. There are no terms which are not containing x. There is x term here, therefore there are no terms which are not containing x, which is equal to c. Now I have to integrate this one. So this will be integral e power x dx. So this value is constant. Y square is also constant and this is 1 by. So already there is minus here. So this value is 1 by x cube of dx is equal to some c. So this value is e power x minus 2my square and this I'll bring it to the numerator as minus 3 into dx, which is equal to 0. After integration I'll write c. This is e power x minus 2my square. So this is minus 3 plus 1 and this is minus 3 plus 1, which is equal to c. And this can be written as e power x minus 2my square x power minus 2 by minus 2, which is equal to c. This minus 2 I can cancel, 2 I can cancel and minus minus becomes plus and e power x plus m, this is y square, x power minus 2 can be written in the denominator as c. And therefore as we can take x square as LCM, this value is x square into e power x plus m into y square, which is equal to c, and our final answer will be x square. See here, this is going to become x square into e power x plus m y square is equal to c into x square. And this is how we have to solve, and this is also so simple. So we have to check whether it comes under inspection method or homogeneous method or 1 by mx minus ny type. And this is the fourth method which I'm going to use, the integrating factor, and my fifth method is also ready to be uploaded. And thank you so much for watching and staying till the end. If you follow one after the other video, definitely this topic will be very easy and you can score well. And if you really like, what to do, please pass it on to as many friends as you can, and that is the greatest help needed. And thank you so much for watching and staying till the end.